All right, Algebra 1, we are finishing up Chapter 6 now. 6.7 is our last section of Chapter 6, talking about linear inequalities. What is a linear inequality? Well, basically it is an inequality that has two variables, x and y, and it's going to be like a linear equation that we graph, but what it's going to do is going to divide the graph into two parts. One of those parts includes the solution, and what we'll find out is that part is shaded. And then one part is not shaded, okay? Greater than means you shade up, less than means you shade down. So part of it's shaded, part of it's not. The shaded part are your solutions. So a solution to these is any point that makes the inequality true, or in other words, points that are in that shaded region. Okay? So, in this case, we can do it algebraically, not always graphically, but here it says determine which ordered pairs are solutions to this inequality. So all we're doing really is plugging these in for x and y. So here's our inequality. So I'm going 2 times x is 2 minus 3 times y, which is 5, less than 15. So let's see if it's true. So I've got 4 minus 15, less than 15. That's negative 11, less than 15. Well, negative 11 is less than 15, so that would be a solution. Okay, and same thing for the others. Let's skip to the 3, negative 4. So I've got 2 times 3 minus 3 times negative 4, less than 15. Well, that's 6 minus negative times negative is positive 12, less than 15. So 6 plus 12 is 18. Is 18 less than 15? No. So that is not a solution. And then 0, 0 is pretty easy because we just go 2 times 0 minus 3 times 0, less than 15. Well, 0 minus 0 is 0, which is less than 15. So 0, 0 would be a solution. Okay? That's how you do it algebraically. Now, graphically, how do we graph these linear inequalities? Well, here's how. First of all, you put the inequality in slope-intercept form. So hopefully by now we know what slope-intercept form is. But if we don't, remember that is y equals mx plus b. So you basically just want to make sure to get the y by itself, okay? And be sure to flip the inequality if you multiply or divide by a negative number, okay? So don't forget those things. So use depending on what the inequality is, you might have to use a solid line or a dotted line, okay? Use a solid line like you would normally for any of them that have the underline, okay? So just like we would have a solid dot, we would have a solid line if there's an underline. And then use a dashed line or a dotted line for any of them that do not have an underline, okay? So it's either going to look like this as a line or like this as a line, okay? And that tells you if any points on the line are solutions or not. And then step 3, you shade up or down, okay? So shade up when the line is greater than or equal to, which should make sense. Shade downward, okay, or below the line for any of them that say less than or equal to, okay? So you got to really think about which is which, okay? So in this case, I want to get y by itself. So the first thing I need to do is get rid of that 2x, okay? So I've got negative 3y less than negative 2x plus 15. And again, look what happens. Divide everything by negative 3. That's supposed to be 15. that should be a red flag. If I divide by a negative, I've got to flip the symbol. So that's y is greater than now. Negative divided by negative is positive 2 over 3. Excuse me. And then 15 divided by negative 3 is negative 5. So I flipped it because I divided by a negative, and now I have everything ready to go. So this is the y-intercept. This is my slope. Okay. So I've got everything there. It is a, look at this, dotted line because it's not underlined, and I'm shading up. Okay, so let's graph it. Negative 5. 1, 2, 3, 4, 5 right here. And I'm going up 2 over 3. Rise or run. Up 2, right 3. There we are. So since it's dotted, I'm going to draw a dotted line. And then I got to shade up. So take my pencil or whatever I'm using and shade above the line. And now I've got that part of the graph shaded. Okay, so that means anything in that shaded part would be a solution. So for instance, 0, 0 is a solution. Okay, so let's do a few more examples of that, and then I'll let you go try it on your own. So here we go. Let's look at this first one because it's already solved, and then we'll go to the next one. So y is greater than. Okay, so I should be shading up, and it should be a dotted line again. Okay, so let's do it. Negative 5 is my y-intercept. So down 1, 2, 3, 4, 5s right here, and then up 1 over 3. I'm going to make more than just that. So up 1 over 3, up 1 over 3. And it's a dotted line, so here we go. I'm going to make a dotted line going that way. And then we shade above. So shade this way, above the line. And it can be kind of fun if you're into coloring, but it's kind of up to you whether you like that or not. But now I know exactly where my solutions are. So if I wanted to list one, I can just pick one. So 0, 0 would be a solution. But all of these points are solutions. Okay, so I don't have to list one here, but if it did ask me, that's what I would do. All right, so let's look at a couple more here. Number 3, it's y equals mx plus b is what I need, so I got to go ahead and get rid of the x. So I've got negative 2y greater than negative 5x plus 12. So now I divide by negative 2, and red flag, dividing by a negative. So since I'm divided by a negative, I gotta flip it. So I flip that around. Now negative divided by negative is positive 5 over 2x. 12 divided by negative 2 is negative 6. Now we're ready to go. But before I do, I'm gonna just note that it should be a dotted line. You don't have to write this down, but it does help, I think. Dotted. And we're going to be shading below or downward. Okay? So, negative 6. 1, 2, 3, 4, 5, 6 is right here. And then I'm going up 5, right 2. So up 1, 2, 3, 4, 5, right 2. Boom. Up 1, 2, 3, 4, 5, right 2. Up 1, 2, 3, 4, 5, right 2. It's a dotted line, so here we go. Dotted line, and I'm shading below, so you gotta just think which one's below, not left or right, which one's downward. So downward would be this side, so I shade below that dotted line. And there we are. Okay, so hopefully that makes sense there. And let's let's look at one more, and then I'll show you the special ones. So in this case, I got to subtract x, got negative y greater than or equal to negative x plus 8. And I divide by negative 1. Once again, red flag up in the air for the negative. So I flip it around. Negative divided by negative is positive. Remember, that's 1 over 1x minus 8. 8 divided by negative 1. So there's my inequality. It's going to be a solid line, and I'm going to shade below the line. So negative 1, 2, 3, 4, 5, 6, 7, 8 is right here. And I'm going up 1 over 1. Up 1 over 1. So it's going up 1 over 1. Oh, this one actually is a solid line, so I don't even need to make dots. So there's my solid line. And then I'm shading below that, which is down this way. Okay, so last two. These ones, remember, if it's y, that means it's going to cross the y-axis, so that's a horizontal line. Okay, so negative 4 on the y-axis is going to be 1, 2, 3, 4. Now, before I do it, it's a solid line, and I should be shading below because it's less than. So solid line, horizontal, since it's going through the y-axis, and I would go below. So y equals is always horizontal because it crosses through the y-axis. But then you look at number 8, it says x equals. So x equals crosses through the x-axis, so it's a vertical line. So that's a dotted line. But since it's vertical, we can't really go up or down. So let's go to 7 real quick. That's a dotted line, vertical line, going through 7. Dotted line, okay? And then it says greater than, okay? So you got to think about what's greater than 7. Well, if it's x values, it's 8, 9, 10. So I should be shading, in this case, to the right, because you just got to think about what x values are greater than 7. Well, everything to the right is greater than 7. Okay? So this is the only time we go right or left. So we would normally shade up, but since we can't say shade up, we would go to the right. Okay? So let me know what questions you have, and if you do have any, we can go ahead and look at that.